Hi, I'm Steve Hutt, Manager of R&D at 18Sound in Reggio Emilia. We've been talking about the semantics and terms of loudspeakers, and we're working our way into the components. Right now, we'll talk about the spec sheet and the general descriptions. We start with the nominal diameter. It is simply the mechanical nominal of the OD, the outside diameter of the frame of the loudspeaker. In this case, we have an 18-inch woofer. Here is a 21-inch, a 15, and a 6. The nominal diameter gives the user a general sense of what to expect in the sound output and frequency range. The next specification is the rated impedance. Rated impedance is useful so that you can understand which kind of a power amplifier should be coupled. The general rated impedances are 4, 8, and 16 ohms. Sometimes we see 2 ohm loudspeakers, and sometimes even higher than 16. The connection between 8 and 4 is that 2 8 ohm speakers could be put in parallel to work as a 4 ohm load to an amplifier, 2 4 ohm speakers in series to be an 8 ohm load to an amplifier, and so on. Next we get to the AES power. And you notice I've copied from our list of the spec sheet. We have a footnote, number 1. Footnotes are really important in the spec sheet. They'll tell you some of the details as to what we're really doing in any of these specifications. So AES power, starting in 1984, AES released the AES-2 specification on testing loudspeaker drivers. There's a number of facets to that standard that have been adhered to and followed by 18Sound for years and years. And then in 2012, a revision was released. There's some changes in the revision. The footnote helps you understand which test we've been running and how that test was run. And importantly, how some things are calculated. Calculated mathematics, we have to remember, when we do a power test, a device is capable of some kind of a power capacity. Between AES 1984 and 2012, the power rating calculation was changed. So it looks like the 2012 loudspeaker can handle less power than a 1984 loudspeaker. And by those years, I'm talking about the standard, not the speaker. The fact is, the speaker hasn't changed. It's just the perception based on the calculation. We use footnotes to make sure that you understand exactly what we're doing with our power. The next power rating is the program power, and that's by 18Sound. It's done with the loudspeaker in an enclosure, and typically we find that we're in the zone of 2 times the AES power capacity. And then finally there's peak power, also with its footnote, but peak power defines a maximum peak limit that the speaker can handle for just some milliseconds, usually based on a mechanical limit. Following, we have sensitivity, also with the footnote. The sensitivity will tell you how loud the speaker will play in dB at a certain position, a distance, and preferably over a frequency range or a specific frequency. Again, the footnote's important to understand how sensitivity is defined. We will typically define sensitivity over a bandwidth with a given voltage input. And finally is the frequency range. We've talked about in one of our videos that loudspeakers are bandpass devices. The frequency range tells you right on the spec sheet the useful range, the minus 3 dB points, minus 10 dB on the low side and the high side. So that's our first bit of the spec sheet. We'll come back and we'll get through a few of the other items. And later, we're actually going to get inside looking at the components and the relationship to how they affect the numbers that come out on the spec sheet. Thanks for watching.